In an algebraic expression, a term is a number, a variable, or the product of a number and one or more variables. Rewriting an algebraic expression as a sum of its terms can help you identify the parts of the expression. Here, the expression 6a squared minus 5ab plus 3b minus 12 is rewritten as a sum of four terms. We can see that on the right. 6a squared plus the negative of 5ab plus 3b plus negative 12. A coefficient is a numerical factor of a term. In this expression, the terms have coefficients of 6, negative 5, and 3. Notice they're the numbers being multiplied by variables that may or may not be raised to a power greater than 1. Terms. This expression has four terms. In an algebraic expression, a term is a number, a variable, or the product of a number and one or more variables. In this expression, the terms are 6a squared, negative 5ab, 3b, and negative 12. Constant. A constant is a term that has no variable. In this algebraic expression, the term negative 12 is a constant. Like terms. Like terms have the same variable factors. To identify like terms, compare the variable factors of the terms as shown below. So we'll start with the terms 7a and negative 3a. The variable factors for each of these terms is a on the left and a on the right. So are these like terms? Well, they share variable factors, so yes, 7a and negative 3a are examples of like terms. How about 4x squared and 12x squared? Their variable factors are x squared and x squared, so once again, yes, they're like terms. 6ab and negative 2a. ab is the variable factor of 6ab, and a is the variable factor of negative 2a. These don't match, so no, these are not like terms. An algebraic expression in simplest form has no like terms or parentheses. So an example of an algebraic expression that's not simplified: 2 times the quantity 3x minus 5 plus 4x. Note we have like terms, and we can distribute that too. On the right-hand side, a simplified expression, 14x minus 10. You can use the distributive property to help combine like terms. Think of the distributive property as BA plus CA equals the sum of B and C, in parentheses, times A. Problem 5, combining like terms. What is the simplified form of each expression? Part A, 8x squared plus 2x squared. We can use the distributive property to rewrite this as 8 plus 2x squared, and that's 10x squared. Now, I often remind students, we can think of x squareds as just being something. It's a thing. And in this expression, we have 8 of that thing, 8x squareds, and then we're adding 2 more of that same thing, 2 more x squareds. So if you have 8x squareds and I give you 2 more x squareds, now you have 10x squareds. Part B, 5x minus 3 minus 3x plus 6y plus 4. Well, first we can rewrite this as a sum. Rather than having subtraction, we have addition of opposites or negatives. That leads us to 5x plus negative 3 plus negative 3x plus 6y plus 4. Then we use the commutative property to rearrange terms and get like terms closer to one another. 5x plus negative 3x plus 6y plus negative 3 plus 4. And then the distributive property, 5 minus 3 times x plus 6y plus negative 3 plus 4. And finally simplify. 2x plus 6y plus 1. Your turn, part A. What is the simplified form of 3y minus y? Part B. How about the simplified form of negative 7mn to the fourth minus 5mn to the fourth? Part C. What is the simplified form of 7y cubed z minus 6yz cubed plus y cubed z? And part D, a reasoning item. Can you simplify 8x squared minus 2x to the fourth minus 2x plus 2 plus xy further. Explain.